So he basically builds models and other sophisticated technical stuff with the help of programming. Thank you.
All right, that's a very long one. But I guess it kind of touches a few of the things that I would have wanted to hear. Well, let's see if somebody else has a different idea. So, Comfort, go ahead.
Okay, data analysis is actually focused on interpreting data using tools, okay, like charts, graphs, and data science actually involves creating tools and creating tools to predict the future trends. Simply, I would say that data analysis helps us to understand what happened, and data science actually helps us to predict what could happen. So that is my answer.
Okay. Well, in a way, that's kind of captures some parts of it because you mentioned prediction. So typically, you will not do, well, you still do prediction in data analysis, right? Because people will say, oh, we don't do prediction in data analysis. Well, we actually do a little bit of prediction in data analysis. So, Hilda, do you want to try? That will be the last one.
Yes. Good evening, everyone. So, well, both of them involves working with data, but my understanding of data analysis is that data analysis focuses more on analyzing past or already existing data, and then it helps you make decision, right? Maybe you want to make an account or you want to summarize a chart or something. Well, data science involves using data to build maybe models of machines or things that can predict future outcomes. And a typical example of that would probably be machine learning and so on. So that's my idea.
Okay, very good attempts by everyone all around. And I think most of us kind of try to touch on it. But what I would say is that I would say data analysis is focused on analyzing data, both explanatory and predictive. But there are other things you could talk about. But data science actually speaks more about engineering the methods, even though I use the word engineering when we're talking about data science, right? But it's about working out the methods by which we would be better able, to analyze data. So data analysis is actually a subset of, it's a subset of data science. Data science contains a whole lot of things, including the data preparation, understanding the ways by which you would ensure that your entire process, is optimal. Maybe I would say so. So it also includes how to collect the data, the methods, the right methods for collecting data, cleaning the data, and then analyzing it. And then even the analysis of the data, you talk about more advanced stuff, right? So, well, having said that, I will just jump into my slides and we'll get into this webinar. So, so the topic today, what we are really going to talk about in general is just what data analysis is, But we also want to talk about opportunities. Why do we even want to do data analysis? Is data analysis the right fit for you, right? So we'll talk about data analysis in general, and then we will delve in a little bit, but I won't go too much into the Python for data analysis, right? Because apart from Python, there are many other tools that can be used for data analysis. There's a whole lot of them. And we've actually had training sessions on the previous ones, right? But today we'll talk a bit more about Python. We'll look at what Python does and what you can do with Python, right? There's a whole bunch of things which you can actually do with Python. All right. So but let's talk about, the background. Why do you want to do this, right? I always like this slide because this slide helps to tell the story, right? So at the top left of this slide, you will see this story that says that according to a report by Korn Ferry, there will be a global talent shortage of 85 million by 2030. So this global talent shortage we are talking about is tech talent. And when we say tech talent, in the different skill areas in tech, including data analysis being one of them, and so many other ones, programming, design, front end, back end, digital marketing, project management, product management, and a whole lot of stuff, right? So there is actually a growing demand for skills that a lot of countries don't yet have. And even for the countries that have the infrastructure and institutions to provide this training or to develop this kind of talent, it is still not enough because the world is basically running on technology right now. And the amount of technology that the world will run on will only continue to escalate exponentially. Maybe there'll be a difference when AI begins to match human intelligence. Then AI will be the ones running things. So yes, there will still be escalation in technology that is running a lot of things and systems, that the world is, power or the world is operating on. But then you will say, okay, AI can manage most of those things. But for now, we need human skills and human capacity. Now, if you put that next to the slide on the right, the top right, you will now see that Africa also has a potentially growing population of young people. So the red line is the population in Asia, right? Specifically young people. While that's a red solid line, while the red dotted line is the African population. So this report was done in 2020. So there is a projection that by 2075, the number of young people in Africa will surpass the number of young people in Asia. Of course, the rest of the world has already been surpassed. So Africa has a growing population of young people. So that's the greatest resource. Of course, this when I speak like this, some people will say, okay, what of those of us who are not young? Which includes somebody like me as well. It's not like I'm old, but I'm also not young, right? And there is also the aspect of pivoting into tech. If you're somebody who already has skill and experience in another domain that is not tech heavy, right? So right now, what's going on in the world is that Africa is the next destination for sourcing tech skills, right? For several reasons. Apart from the growing population of young people that has been mentioned, there's also the fact that it's also becoming more cost effective for a lot of businesses to look for a talent in Africa. And let me just put it that way and end it that way. So there is potentially a lot of opportunities coming to us, coming our way. And these opportunities are in various areas of tech. Now, this is the other side of that coin, the side that says, in Nigeria in particular, right, we have a large amount of unemployment. 3% of the workforce are unemployed, 23 million people, right? Now, if you do it further, 39.1 million, which is 56.1% of that workforce are either unemployed or underemployed. So in this case, those who are underemployed have been added to that number, to the 23 million, we have 39.1. So underemployed in the sense that they have more skills than their job is demanding of them, right? They are better skilled, they could do much more, but there are no jobs, or they are not doing any jobs that take their full capacity. And then, of course, speaking of youthfulness, 60% of Nigeria's workforce are below 34 years of age. That's a total of 41.8 million people. That is on the left, Bloomberg report. On the right, NBS, National Bureau of Statistics, tells us that of that 3.3% that are unemployed, you see the breakdown, those who are underemployed, those who are youth and unemployed, those who are youth and underemployed, and those who are unemployed but have advanced education. Advanced education here means first degree and above. So the question you ask is, how do you balance these two sides? We are saying there's a lot of demand for tech talent, and yet we are saying there's a huge amount of unemployment. Does it make sense? How can there be demand for people, and yet there are a lot of people, looking for jobs? Of course, the answer to that question is a lot of people were not trained on the skills that are currently being demanded in the world today. A lot of people were trained in skills of the 20th century or even the 19th century. That's what is going on. And because of that, this is the 21st century. The skills that are needed in the 21st century, a lot of people do not have those skills. So even though they have advanced education, they have, a lot more skills, and they are underemployed, but those skills are not the skills that we need in the economy of today. The technology-based skill ecosystem, the skill workforce of today. So the solution is for you to ask yourself, how do I skill up? And that's the essence of this discussion. How do you skill yourself up? You are looking for a job. You are looking for a better paying job. You are looking for a more fulfilling job. And maybe all this while, all your life, people have been telling you jobs are scarce. And now somebody comes here and tells you jobs are plenty, brekete. The problem is that you were learning the wrong skill. Well, let me not say the wrong skill. You are learning a skill that is no more in demand. So what do you need to do? You need to pivot and switch and learn a skill that is currently in high demand. And this slide gives us a summary of the tech skills that are in high demand in the world today that you should learn. And remember, I'm saying tech skills. I'm not saying these are all the skills. If you're a medical professional, yes, those are still in demand. Maybe even engineering, right? Especially if it is the more modern, forms of engineering, including electronics, mechatronics, even, petroleum and gas, and a whole lot of others, right? But in the area of tech, these are the skills: cybersecurity, project management, DevOps, programming. Programming is basically almost everything else, right? Front end, back end, mobile, security, software testing, right? Data analysis, there we go. Data science, those two. UX, user experience design, user interface design, digital marketing, communication, Java cloud computing, Java is a specific programming language. AI, artificial intelligence, software development, which is the same as software or programming, even though software development is broader than programming and requires an additional bunch of skills beyond just programming. There is blockchain. There is Python. There you go, Python. Python just came out on its own, even though it's amongst a whole bunch of other programming languages, right? But if you look at it, only 3 programming languages have been mentioned on this simple search result. By the way, this search result is from Google. And the 3 programming languages I mentioned are Python, JavaScript, and Java. So that already tells you where the demand is, right? Encryption, JavaScript, machine learning, cloud computing, right? And a whole bunch of these other things. Mobile development, you can see it there. Sustainability skills, machine learning engineering, risk mitigation strategy, right? So you can see right in the middle at the top there, data analysis. So there is a high demand for this skill. So you don't even really need somebody to tell you, or you don't even need to ask, okay, what should I do data analysis or not? Because there is a high demand for it. Now, when we talk about, this is another search, basically. This search was based on non-tech skills. So when I say non-tech skills or non-programming skills, skills that do not require programming, right? Top skills that are demanded but don't require programming. So you still see project management, UX design, cloud computing, digital marketing. Even though cloud computing does require a little bit, well, I wouldn't call it programming. It's more of scripting, shell scripting, and so on, right? Digital marketing, content marketing, search engine optimization, business administration, tech support, business analyst. There you go. Data analytics, data analysis. Again, AI, artificial intelligence, which is basically using the tools built by AI, to solve problems. Graphic design, software quality testing, software development, cybersecurity, UI design, product management. So technical writing, machine learning again, social media, which is basically marketing, tech support. So the previous slide included some programming skills, but here was entirely no code, what you could say no code skills, right? Or very little code skills. Machine learning, you can also do it with no code, but because we have a lot of really great frameworks that you can actually use to build training pipelines, entirely, end-to-end training pipelines. You push in your own data, you design the models, right? You configure your training pipeline, you train, and you get trained, connect those trained models to a framework, and they give you something, right? So there are frameworks that do that now. So that's why machine learning can also be considered that. But I can tell you machine learning still requires a bit of programming. So you see data analysis coming through. And now let's look at the incentive for you to go do this. These are top paying tech jobs, right? If you look at the top paying tech jobs, you will see that data science is right up there, along with software engineering and DevOps. You can see 100,000 US dollars per annum. So this is like in the US, right? This is moderate. There are those who earn more than this, and there are those who earn less than this. So this is kind of average. If you look to the left, so that was somewhere on the right. If you look to the left, you will also see, you see data analysts there somewhere, right? 17,700 job openings. The salary range is between $52,000 to $78,000 per annum. The median salary is 67,815, right? And it's right up there with the others, including web development, motion design, digital strategists, marketing managers, researching, and so on and so forth, right? So this is, for me, a sufficient incentive for anybody who wants to jump into data analysis, right? Or maybe as a data science, jump into data scientist, data science as a data scientist, rather. So having gone through all of that, maybe that will help us kind of put it in perspective and ask ourselves a question. Do I really want to do this? Do I want to go through, the amount of stress and strain that is needed for me to learn these skills? Is it worth it? That already tells you. So the question now is, what is data analysis? So I had asked this question earlier, what's the difference between data science and data analysis? So here is what data analysis is. It's basically a process of getting insights from data to inform better business decisions. This is what it is, right? And it has become a very big skill, high demand skill in the world today, because the world today is largely driven by data. In the 20th century, there wasn't a lot of data, so there wasn't a high demand for it. But here you have floods of data coming in, on a per second basis, on a daily basis, into different organizations. Organizations are gathering data, even if they have the infrastructure for it or not. They can even outsource the gathering of data. If you build, if your company has an app or something, you're already getting data. If your company has a website, or the company you're working for has a website, that's a lot of data coming in. Or even if you use any of these cloud platforms that are now available, where you can pay on a pay use or pay as you go basis, those platforms allow you to collect data. So there's a lot of data, and the world is driven, business today is driven by analyzing that data. You don't just guess or try to imagine what your customers' needs are, or what your customers' preferences are, or what works and what doesn't work. The data is right there, right? So even in your business, to analyze business performance, the data is right there. So the question is, who can analyze this data and provide better insights to the top management of a company or of a business, so that they can make better decisions? That's the question. Who is this person? That person is a data analyst. And the better you are at analyzing data and gleaning these insights and passing it on to the management and stakeholders in a company, in a business, to make better decisions that help growth in the business, then the better you are, as a data analyst, and the more in demand your skills will be, right? So this is just the basis behind it. And the process of analyzing this data, typically you go through these 5 phases, which are iterative, so you can keep cycling around them. First of all, you have to identify the data you want to analyze. Then you collect the data. Then you clean the data in preparation for analysis. Then you analyze the data. Then you interpret the results of this analysis, right? So you can see that data analysis can take different forms, right? And it's based on what information you want to glean, the question you want to answer, what your target or objective is, right? And there are different types of data analysis, right? So we have what we call descriptive analysis, which is like the first step in data analysis, which is to explain what happened, right? To explain what happened. You look at the data and you try to explain what happened. Like maybe, let's say, it's just what happened. That's descriptive analysis. That's the first step. Then the second step is what we call diagnostic analysis, which is after you have explained what happened, or the next thing is to figure out why it happened. What were the triggers? What was the causal event? What led to this thing happen? What were the conditions or the situations that led it to happen? That's diagnostic analysis. And then after that, the next level is what we call predictive analysis. And predictive analysis is basically saying, can we predict this event, and can we stop it from happening? Or can we prevent a similar thing from happening? Or can we even try to figure out, what happened and predict what may happen in the next 1 year, 2 years, 5 years, 10 years, right? Basically, with a predictive analysis, you're able to say, based on what has happened in the past, this is most likely what will happen in the future. Then the last one, and perhaps the most powerful one, is the prescriptive analysis, which is after predicting what may happen in the future based on the data you have in the present and the past and building models. You can then even recommend, solutions or things or actions to carry out so that you would have specific outcomes. And that is still kind of predictive in a way, but you're now prescribing actions rather than just saying this is what will happen. So at this other end of data analysis, where you talk of predictive and prescriptive, that's when you now have to build models. That's where machine learning actually comes in, because building models basically requires, a bit of machine learning and so on. So this is what data analysis is. So you can see that data analysis, when you say machine learning, data analysis doesn't include machine learning. It actually is not very correct, right? But what makes data science different from data analysis is that with data science, you also pay attention to the mechanisms, and you can decide on the methods as well. You can improve on the methods. You can study the methods. You can study the mechanisms, for all of these things that we are saying. Right. So why does data analysis matter? Why do we have to do all of this? Because like I just said, data is like the new oil, right? A flood of data keeps coming into businesses, and businesses need to make sense of this data in order for growth and profitability, right? So being able to analyze data, and not just analyze it, but glean the insights from it, and not just glean the insights, but from the insights, get actionable, items, actions to be carried out to kind of direct the outcome in the desired, direction. That is what makes data analysis powerful. So examples that you see in marketing, you can talk about optimizing campaigns, right? Finance, you can predict market trends, and not just predict market trends, but you can even figure out what actions a business would take in order to seize the initiative or turn these market trends to their advantage. In healthcare, you can use data analysis to improve treatments and outcomes. This is just one example. In retail, you can use it to understand customer behavior and fine-tune your own business policies and practices in order to get the best, basically, to improve your customer base. So in that context, what does a data analyst do? A data analyst is somebody who collects data, cleans the data, interprets the data set in order to answer a question or solve a problem. And the data analyst works in any industry. So this is the interesting thing with being a data analyst. You can work anywhere where there is data, whether it's in business, whether it's in finance, criminal justice, in science, in medicine, in government, anywhere. So whenever you hear the word analyst, attached to a person's title, that person is just doing data analysis. Whether it's a business analyst, a financial analyst, a sales analyst or whatever, just think about that, right? You are analyzing data and you are coming up with solutions, recommendations to make things better for the business. Now, one thing I would like to say here is, if you are in any particular area as a data analyst, having domain-specific knowledge also gives you an added advantage. So for example, if you're a financial analyst, having knowledge of finance gives you an extra advantage because you are better able to glean the insights when you understand the mechanisms of finance, for example. If you're a business analyst, understanding the business, whatever that business is, gives you, an advantage. Because when you analyze the data, you can then bring to bear your knowledge of the business and use that to give better insights, to the business, to the company, to the management. And essentially, you are more likely to be successful at changing the outcome if you have some prior knowledge, what I call domain-specific knowledge. Okay, so good examples of the kind of questions, like a data analyst would answer would be something like, what kind of customers should a business target in its next ad campaign? Like you're doing ads and you are not, you need to, hey, is this ad, am I spending my money well on these ads? Am I getting the expected outcomes, right? So what demographic should I target in this ad campaign or next one? What age group is most vulnerable to a particular disease? This is in the context of healthcare, right? What patterns in behavior are connected to financial fraud? So this is what maybe a financial analyst would do. So these are the types of questions that your team, your company will ask you as a data analyst, and you're expected to provide answers. And your answers will not be guesswork. Your answers will come from analyzing data that has been given to you. So I think I've already talked about this somewhat, right? These are the roles and responsibilities for a data analyst. You gather data, right? Sometimes you have to collect it yourself. Basically setting up data collection mechanisms, whether you're using surveys, whether you're tracking information on the company website, or whether you're even going somewhere to go and buy data sets from people who are specialists in collecting data, right? So you find ways to gather the data that is relevant to what you are trying to achieve. Then after that, you now clean the data, because the data you want to analyze, there are expectations or assumptions that the data is perfect. But real world data is never perfect. You have duplicates, you have errors, you have outliers, you have empty, records that don't contain anything, right? So being able to clean this data is very key. And cleaning data means maintaining the quality, either in a spreadsheet, right? Or using programming language. So in this case, like Python, which we'll talk about a few things, so that, your interpretation of the data won't be wrong or skewed. Then after that, you model the data. So what does model mean? Data essentially is a whole lot of information that comes from different people, from different, sources, right? Now, a model is essentially, a representation of that data, right? That has been kind of condensed. In fact, let me put it simply, it has been condensed into a mathematical equation. That's really what it is. A model is a mathematical model. That's why it's called a model. It's a mathematical equation that represents that data, and it is fit to that data, so that if at some point in future you need to use that data to make some assumptions or predictions, it will be very accurate in making those predictions, simply because that model represents that data, accurately. But of course, in real life, models do not always represent data accurately. So the quality of your model depends on how well it represents the data, right? So you have to establish that relationship, and you have to then use any of a number of different processes to model the data. And there are so many of them. We'll actually talk about that a little bit when we are going into data modeling. Talk about, how you model data. Then after that, you interpret the data. The model helps you to interpret the data. You also look at the patterns. You look at the trends in the data, right? That helps to answer questions. Then the model also helps you to do predictions, because with the model, you can put in input conditions that don't yet exist, and it can try to predict that what if those conditions were, present? How would the outcome look like? That is where prediction comes in. Then the final part of data analysis is presenting that data in a way that is impactful to the audience. When you have analyzed data, you don't go and give people that raw data that you analyzed. You rather give them insights. And the insights have to be in a way that it's easy for them to grasp the aspects that are most important, right? The ones that matter. They are not supposed, when you are presenting your insights to either your team or your management or whoever commissioned you to analyze that data, you're not expected to go and give them all the nitty-gritty, all the details, all the raw data. You're expected to give them, insights, summaries, action items. So typically, one of the most powerful methods of communicating these results of your findings would be by using visualizations. Visualization is like charts or graphs, right? That will show it in three-dimensional form or two-dimensional form graphically, so that people easily see it, right? What people see, they remember better than all the long statements that you would make, okay? Then the other way you could present the result of your analysis is to write reports, and then of course you have spreadsheets and other forms of data representation. So these are your roles and responsibilities as a data analyst. You have to have all of these skills. Right. So this is just another slide to talk about how much I can make as a data analyst by role. From a junior analyst that makes maybe $61,000 per annum, all the way up to those who are managers and directors who can end up to 160, 170,000. Well, this is just representative. There could be even more, right? There could be even more, and it could also be less. All right. So when we talk data analysis and data analysis, right? The question is, what are the types of data analysts that we have? So I just mentioned this earlier, somewhere at an earlier slide. Because we have so much technology, we have so much proliferation of data, right? So knowing how to gather, sort, and analyze this data is a crucial part of any industry. So that's why you will find in today's world, you find data analysts in almost every sphere of the public, every part of public sector, right? You will see in medical care, you hear, medical analyst or healthcare analyst. You have other titles like market research analyst, business analyst, like I said, business intelligence analyst, operations research analyst, intelligence analyst. And this is just one of many. There are so many others, like I have already mentioned before. Okay, so what are the skills that you are expected to have as a data analyst. One, being able to use database tools. So Microsoft Excel is one powerful tool. And the Excel has a whole ecosystem of tools. Apart from Excel, you have a Power BI, you have Power Query, and all of that, right? Then you have SQL, which is another database tool, which you can use to analyze a lot of data in databases, right? Especially large data sets, because Excel is not very strong when the data sets get into millions or hundreds of millions or even billions of records. But for SQL, it can handle that. The second skill that you would learn is a programming language that is very good with statistical analysis, like Python or R. And that brings us to where we are going to talk about Python for data analysis. Okay. So I think Python and R are like the most common. We're not going to look at R in this, in the class. We are going to look at Python. We're going to look at data analysis, and then we're going to talk about how to use Python for data analysis, right? It's good to look at job descriptions, for any position you're interested in, to see and which language you should learn. But I think if you go with Python, in fact, not I think, I know if you go with Python, you really cannot go wrong, right? Then data visualization is the other skill you need to learn, which is how you can present your findings in very interesting, clear, compelling ways, right? Either as charts or as graphs, right? And using all the tools available. So good tools that we have, I already mentioned Power BI as a very good one. Tableau is also a good tool. We have Jupyter Notebook. Jupyter Notebook is actually a tool that comes with Python. Then Excel as well. Then last but not least, yeah, we may think that we cannot run away from it, or we can run away from it rather. But statistics and maths will give you a lot of additional advantage as a data analyst, right? Because you need to know the concepts behind all of these tools and what these tools are doing. When you hear of things like regressions, fitting a curve and all those kind of things, if you understand how those work and statistical concepts in particular, right, it also helps you to better interpret data. If you do not have statistical knowledge, your knowledge of data analysis will be shallow, and your ability to interpret and to give insights to your team will be limited, because you may make mistakes in how you interpret data if you do not understand statistical concepts like sample size, and error bars and error, intervals and all of that kind of stuff, right? So that is something else to think about. So the tools that we can use for data analysis includes, I already mentioned it, Microsoft Excel, Google Sheets, SQL, Tableau, R or Python, SAS, Microsoft Power BI, and Jupyter Notebooks. So in this course, when we start, we are going to use Python, and we're going to use a lot of Jupyter Notebooks in order to easily analyze data. Now, this is a summary of the curriculum that we will look at. If you were doing a larger data analysis training curriculum, right, you go through all of this. But I think for this class, we are really just going to focus on Python analysis tools, Jupyter Notebook. So the last 3 bullet points here is what we will do, right? And so this slide gives you an idea of what this training curriculum will go into. So we are going to look at Python basics. We need to learn basics of Python. We're actually going to learn a bit of programming. I'll try to minimize the programming part so that people don't run away. But we need to understand some of the basics, variables, constants, loops, conditionals, and all of those simple things. Python is a really simple programming language to grasp. It's it has the same programming concepts, but it is actually much easier to apply them. Then after that, we'll go and look at what we call Jupyter Notebooks, which is a Jupyter Notebook is basically a web-based tool that allows you to write Python code and execute it. Very easy. It's very simple to use. You write code, it gives you the results, right? Then Pandas. Pandas is a very powerful data analysis tool in Python. It allows you to analyze tabular data like a spreadsheet. In fact, Pandas is basically like a spreadsheet in Python. But of course, because Python is a programming language, it doesn't really have, it's not a UI-based kind of thing, right? It's not like Excel that you have the spreadsheet and you'll be typing the data and you'll be seeing the data as you are typing it in. No. Pandas, you have to imagine the data, but you have to imagine like you are using a spreadsheet and the data is in there, right? That's how Pandas is. Programming basically requires a lot of imagination. So if you do not have imagination, you won't be a good programmer because you have to be able to carry a lot of things in your head and maintain all the relationships, while doing that. Then we have Matplotlib. Matplotlib is a library in Python that you use for plotting graphs. It's not a very powerful library anyway, but you can use it to plot some basic graphs and things like that and visualizations. Then we have Seaborn as well. So the other things you learn, data structures, I already mentioned this. Data structures are very important because that is what you use to represent data. So for example, you have lists, tuples, you have dictionary sets and NumPy arrays. So these are just words which will be explained to you what they mean and what they do. Then you have data wrangling. So data wrangling is basically a concept that has to do with how you can clean and transform your data set. So that is when we'll start doing the actual data analysis with Python. We'll use Pandas. Pandas will be one of the main tools for doing this data analysis because the Panda is, like I said, allows you to think about it like an Excel in Python. You can do almost anything you would have done in Excel, but you are not going to type in the numbers directly. You're going to write code. You're going to write Python code to manage those numbers. And you will do it in bulk, in large scale, right? Then we have what we call EDA, which is exploratory data analysis, right? So you can already take the data from a data set and begin to see relationships between those data, see the patterns and correlations by running some kind of tools on that data. And then you have data visualization. So like I said, using bar charts, scatter plots, trends, and other kinds of charts, pie charts and so on, using Matplotlib, which is like a basic plotting library, a basic charting library in Python. And then Seaborn, which is a much more advanced toolkit for managing data. And then after that, we are going to look at what we call time series analysis. So time series analysis is basically analysis of data that changes with time. Data that has timestamps, data that changes as the time goes on, being able to analyze all of those. So that's time series data. And we're going to look at how to do that, how to manage time series data, how to analyze it, right? Looking at trends, timestamps, and time-based insights. Then we'll now do advanced data manipulation using Pandas again. So we talk about merging data, reshaping data, creating pivot tables. So it's interesting because people did not realize that you could do pivot tables with Pandas and all kinds of other things. But like I said, think of Pandas as a kind of huge spreadsheet, powerful spreadsheet functionality that you can access it and program it, from Python. Then after that, we'll look at workflows. So a lot of the things that you would have been doing manually in a data analysis scenario, you can then use Python. That's the power of Python over all the other methods, over the Excel, the Power BI, and so on. You can actually then write scripts and write some code that will automate a lot of tasks. So that helps you, because when you have a lot of data, you don't need to redo the whole thing all over again. Just run your automation, pipeline, and the data comes in and the insights come out. And this will be something that will be super impressive to all your bosses, because they will say, man, this guy, this data just came in and it's already telling us what will happen, right? Then we'll now look at the last part of it, which we call the predictive analysis, predictive and prescriptive analysis, right? So we'll learn how to predict future events or other scenarios. Apart from future events, will be predicting time series data, but there are other ones that it's not really time-based, but situation-based or parameter-based. You can predict those other scenarios based on the existing data and the model that you have built around the existing data. So we can use, we are going to look at things like regression, linear, logistic, and polynomial kinds of regression. We are going to use scikit-learn. Scikit-learn is a Python library that allows you to do lots of regressions and predictive modeling. I think we'll stop there, right? Because beyond this, we could go into, but that's for, we'll have a separate class, a separate training session for data science, where we'll now start talking about more advanced stuff using neural networks, using Bayesian probability statistical models, using things that we call like clustering algorithms, a whole lot of stuff there, right? But that will be for a different class. So for this one, we will just stop at predictive models, and then we are going to do what we call a capstone project, which will allow us to analyze the data. And you'll be given data, you analyze it, you share insight, you do your visualizations and all of that. So this is just a reminder, opportunities in data science. This is different from data analysis, but you see, these are the kind of jobs that you will do when you have skills in data analysis or data science, right? You can do any of these and many more, like we've already mentioned. So I'll just end this with this. Why did we choose Python for data analysis? Like I said, Python is very easy to learn. With Python, we don't need to start thinking about the programming aspect. We'll quickly go past the programming aspect and start thinking rather about the data analysis aspect, because I don't want people to get bogged down with the programming and not make progress simply because, hey, I couldn't write this code or this or that, right? So we'll get past that quickly, and then we'll go and start looking at the tools, the powerful libraries that Python has. Like we've already mentioned, pandas, which is like data frame based, spreadsheet kind of thing. NumPy, which is used for, very high speed analysis of numerical data, right? That's why it's called NumPy. When you want to do regressions and all kinds of predictions, you use NumPy. But it's numerical. It doesn't deal with strings or sentences or words. Everything is numbers. So you have to find a way to convert your data into numbers and represent them with numbers. And then NumPy, you will use them to analyze. Matplotlib, like I said, for plotting graphs, Seaborn, and so many others. Python has a lot of powerful libraries. We'll touch some of them, not all, but we'll touch some of them, and you'll see what you can do with Python. And then Python is also very versatile. It's used across multiple industries. Python is used for web development, by the way, both front end, back end, and monolithic, right? Python is also used for machine learning and a whole bunch of things. So it makes it really easy for you to integrate into existing tools. And then finally, and perhaps most importantly, Python is a free and open source programming language. So you don't have to pay money to use it. you don't have to pay money. Well, you don't have to pay money to learn it, but this time around, I think you have to pay money for this particular course. So yeah, so these are examples of Python, in action, examples, and so on. Yeah, then you can look at some of the real world applications of Python for data analysis. You have business analytics to analyze trends and improve processes. In finance, for forecasting investments and detecting fraud, like I said, you can actually train models that will detect fraud, what we call anomaly detection or fraud detection. In healthcare, to analyze research data for better treatments. In marketing, to understand and predict customer behavior. In sports as well, to analyze performance statistics. So these are some of the current applications that people are using Python in data analysis to do. And you will learn how to do some or all of this by the time we finish this course. So I'm going to just quickly talk about this. This is an area, well, it's not really related. It's generally related to the idea of you learning tech, the future of work. I'm just going to summarize it quickly. The world is changing. That's what this slide is saying. And there are 7 disruptors, 7 things that are driving this change. 1, technology is everywhere. 6 billion plus smartphones in the world. Well, this was by 2020, but we're in 2024 now. So think about what the number is. Almost everybody in this call has a smartphone. In fact, I would say everybody in this call has a smartphone. That's the first factor. Second factor, tsunami of data. A lot of data coming in from so many different sources, including the very smartphones we just talked about, right? There's a change in nature of a career, right? So now careers are no more those long-lasting 30-year, 40-year things, but things that now last from 2.5 to 5 years, by which time you move on to something else, because that's it. Number 4, jobs are now vulnerable to automation. And this was in 2016, before AI. Now AI is basically disrupting everything. There's explosion in contingent work, right? And then finally, AI, I just mentioned that. Cognitive computing, robotics is now affordable. The final factor is the diversity and generational change. So the people we call millennials have reached 50% of the workforce. In fact, now we are talking about Gen Z, who are also growing into the workforce. We now have Gen Alpha. So we are in a situation where a lot of people, things are going to change. What all of this basically points to is that the skills that you currently have or you thought were important are now almost all obsolete. The way we do work will change. It has already changed. As at 2019, when COVID-19 came, the way we work changed, right? Now people work remote. They sit in their homes. We have meetings just like this webinar we're having here. And people can work and produce results. A lot of the work that we do is no more based on things like agriculture, manual work. I'm not saying agriculture doesn't work, but all of that is automated. So we have automation, we have tools that do that much better than human beings, right? They do them faster, they do them more precise, they do them better. So the question now is, what will be left for human beings to do? What will be left for you to do? It is building those tools that now automate those processes. That is what work will look like. And there are 3 factors in the future of work. We call them the 3 Ps or the 3 Ws, depending on whichever nomenclature you choose. The 3 Ps, people, place, process. The 3 Ws, workforce, workplace, work. They all mean the same thing. Basically, those are the 3 things that will change, right? So, first of all, when you talk of the people, you now have people who are more engaged and empowered, who are now aligned to new digital skills, right? When we talk about where are you working? Before, it was silos, offices. Now we're talking about connected, more secure work environments, independent of place or time. Independent of place because people are working remotely. Independent of time because even time zones, across different time zones, people are working together. and even across different points in time, right? And then augmentation. You now have collaboration between human beings and technology. Our skills are being augmented. Our capabilities are being augmented. The fact that you're even using ChatGPT right now to do whatever you are doing, whether it's to write code or to write articles or whatever, that's augmentation. The fact that you're even using a tool like Excel to analyze data, that's augmentation. So that is a new direction. And all of these things are intermingled. This is basically what this is. If you do not key into this new paradigm, this shift in paradigm, you are left behind. You will not succeed in the new, you know, in the new work, what I would call paradigm of work, the new environment of work. And that's what we mean by future of work, right? You can see that what we call the employee has evolved over time. The one above in white is the past. The one in green below is the future. In the past, people work 9 to 5 from a single office. But now people work anytime, especially if you're doing remote work. Nobody's really looking at how many hours you work or what time, time interval or time, the time frame or the time that you start and the time that you close. Rather, they look at the amount of work that you put out, its output. In the past, you have to go to a corporate office to work from there, but now you can work from anywhere because there's connectivity and all tooling is now virtual. In the past, you use company equipment to do your work. If company doesn't provide you equipment, you don't work. You sit down, you blame the company. Now you use any device, sometimes your own devices to do work and you deliver. In the past, you focused on inputs, how much effort you have put in, how much time you have put in, how much energy you have put in, how much thought you have put in. But now we focus on output. It doesn't matter how much you have put in. What matters is how much you put out, how much you deliver. The focus now is, and it's only natural because you cannot really control what people put in a virtual environment. So it's better you focus on them delivering what is needed. And if they deliver, well, they've done it. In the past, we focused on people climbing corporate ladder from coming in as a brand new, fresh employee and climbing up the ladder to become, a CEO or a manager or something. But these days, people create their own ladder. You make your own ladder, you grow yourself, you become better and better. And sometimes you even, you don't stay in one company long enough to become anything. But personally, you are growing, you have personal growth. Before, there was predefined work. You are told exactly what to do. But now you have customized work where you have to determine what needs to be done. The focus is again on deliverables, right? What you are able to achieve, not what work you're actually doing. In the past, people were hoarding information because for them, it was, a competitive advantage. If I hoard this information, only me has this information. So that means I'll be better than my fellow employees. I'll do better because I have this information they don't have. That was the old paradigm. But now you share information because everybody does well. And if the team does well, everybody does well. Sharing information is better. That's why open source is now more powerful than proprietary in any sphere you want to look at. In the past, people did not have a voice. You just sit down and do what you are told. But now you yourself can become a leader in that company. There is encouragement for growth. In the past, we relied on email. Email was like the primary means of communication. But now they are saying collaboration technologies, real-time communication, using chat, using Discord, using Slack, using Teams. These tools where it's real-time and it's asynchronous, or compared to before where you had to send emails and wait for the person to read it and respond to you and all of that. In the past, people were focused on knowledge, right? But now people are focused on adaptive learning. There was that before, that focus of, do I know this? I need to go and learn this. But there's so much to learn now that you have to just be adaptive. In the past, the focus was on the company teaching you, learning and teaching from, corporate level. But now, teaching and learning is democratized. Information is free. Knowledge is free. You can get it. The only thing you probably have to pay people for is, if they have to teach you, you cannot learn it yourself. So this is the future of work, and everybody needs to learn this. The most important thing is that you become your own boss, not in the context of everybody must own a company, but you become your own, you define your own, let me use the word destiny. You define your own growth. You define what you become, right? You define how successful you become. You can do that in the world of today. So I'm just going to end this with that little piece. It wasn't really data science or data analysis per se, but it was generally, this is how your mindset needs to change in order for you to become successful. So that was that was Jara for everyone. With that, I have come to the end of my presentation, and we can have maybe 10, 15 minutes for questions and answers. Thank you very much for listening.
Okay, thank you very much, sir. Please let's give him a round of applause. Use your reaction icon on your chat and give him a round of applause. Please, I want to see everybody clap. It's not easy. Thank you very much, sir, for that session. So yeah, we've covered a lot today, and it's now your turn to ask questions. The floor is open. Please do well to raise your hand if you have a question, and I am going to call you to ask your question. And you can also use the chat session to ask your question as well. So if you have a question, please raise your hand. I'm sure we have learned a lot, and I'm sure a lot of persons have taken notes. So if you have a question, please raise your hand or use the chat session. Okay, Clement Obadimo, your hand is raised, sir. Please go ahead, unmute and ask your question.
I want to specifically thank this opportunity. I had attempted to get deeper understanding. My nature of work is so voluminous, it's not allowing me. And I hope that this opportunity will create that, will allow me, taking cognizance of some of us who has this challenge of coping with other work. I'm very happy because Engineer Nibit has been able to remove what he already thought as a challenge to some of us who are coming into tech, and that has to do with extreme programming. So bringing us into such a way that we are able to, I remember those days when we have MS-DOS, and all of a sudden, Microsoft Windows just came up, and people were able to go through Windows instead of using those MS-DOS approach. So with this, I think it's going to be an easy one for us. My question is already asked, how flexible they can make it for some of us to join or catch up. Two is the financial implication. The first one is more like flexibility, and it is then two is financial implication. And I think the third has to do with, if I remember, I will drop it on a note. I just have this passion to see how I can get on this thing and join. Thank you. Thank you so much.
Okay, thank you very much, sir, for that. Okay, to answer your question, how flexible will it be? It's going to be very flexible, and when it starts, you're just going to see how flexible it is. We made sure that it's accommodating for everybody of every category. right? And for the financial aspect, before the end of this call, the amounts for the upcoming Python data analysis training is going to be mentioned. So just sit tight. Thank you very much, sir. So Samuel Ojo Samuel.
Sorry, before Samuel, I also want to, Doc, I didn't even know you had joined the call, but thanks for joining. I want to, in your own case, I know what you're asking, right? Because yours has a specific purpose. Let me put it that way. So this Python, this one is a general one, but remember we are going to, and I'm going to bring that up. Maybe I'll just also put it out there so that everyone who is interested will also learn. Now, what we are doing now is data analysis with Python. But I know that what I have discussed before with you has been machine learning with Python, but a kind of machine learning that applies in the context of research. So that is a different one from this. But maybe I'll talk about it at the end of the questions, because it does look like there may be a few people in this call who may be interested in learning machine learning for research using Python. So yeah, I'll talk about that also later.
As a matter of fact, I actually hurriedly invited some of the professors who are interested in that, and they're also on this call too. Yes, I'm aware we're talking about that one. I still want to leverage on this general overview and introduction, knowing fully well that if I grab this, the other one too will be easy for me to understand. So thank you.
All right, noted. So I'll talk about that at the end of the question and answer session. Thanks.
Okay, thank you. Samuel, please go ahead.
Okay, thank you so much, Engineer Nevet, our co-host. I want to sincerely appreciate you for the explicit session this night. My question is concerning the subject at hand. Some of us on this call are like, how would I call it, either a returnee or
Hello, Samuel.
school. Yeah, the end around October or November. So I just wanted to find out whether there's going to be a special consideration concerning some of us that I want to assume I've actually ended the last session.
Okay.
Yes, and to see how for us, please. So I think that's just my question to Engineer Nebet. Thank you so much.
Hello, Engineer Nibet, sir. Can you hear me?
Yes, so like you said, I'll talk about that at the end when we're talking about the cost for the training program. So please, I need a reminder in case I forget. So someone I'll address that later. Thanks.
Okay. So do we have any other question? I only had 2 hands raised. Any other question? Okay, after everything Engineer Nebet said, we had only 2 questions. Ouch. Okay, so I want to believe we all understood everything he said clearly, and that's a good one. So to move forward, more like the next step and action points. So the course of this webinar was there's a hand raised. Whose hand is that? Okay, Emanuela, please go ahead. Do you have a question?
Okay, hi. Yes. So I wanted to understand. So does this replace SQL Excel and maybe Power BI?
If it replaces it,
Yes. So with this Python for data analytics, can you do visualizations and every other thing using it instead of incorporating maybe Excel? You want to, do one or two things like cleaning in Excel then, because some organizations will want you to have knowledge of Excel and SQL. So that's actually what I want to know.
Yeah, so it doesn't replace Excel or SQL, right? As a matter of fact, we have a separate data analysis training. That is why the name for this training is data analysis with Python, right? We have a separate data analysis training that has all of what you mentioned: Excel, Power BI, Tableau, SQL or SQL. And yeah, so we have that as a separate course. And then we have data analysis with Python, a separate course. We typically do that one.
Advanced.
Sorry?
So should we say this is the advanced?
Yes, this is the advanced. This is actually the part 2,
So
right? You start with that one,
part
and then you
2,
do this one, and then the part 3 is the one that I'm going to talk about, which is now machine learning, right, with Python. So the whole data analysis is going to be made up of 3 parts, starting with the the one you just mentioned as the beginning. And you can choose any one you want to do, or all 3, or 2 out of 3, depending on where your interest lies and where your existing skill set already lies.
Okay. Okay, thank you.
All right.
okay, thank you very much. One more chance. Do we have any other question?
Yeah, yes, please. When is the training going to commence and the duration? Thank you.
Yes, we are getting to that. We are getting to that. Thank you. Okay, so talking about the training, so that is the next step. The Python with data analysis training starts in January. That is where you learn, as Engineer Nebert has said, that is where you learn everything you need to know and you need to become confident in your field, right? So there are 2 links on the chat session. One of the link is the registration link for the upcoming data analysis with Python training. And the second one is the link to the WhatsApp group for you to join, where you're going to get updated information and where you're also going to drop your payment proof. The training is just a sum of 50,000 naira, and that is a discounted amount for everybody on this call, right? The essence of this webinar was to make sure that we get to see the people that are serious, and so that we can, give them that discounted offer. But after this particular one, the next one is not going to be 50,000. So if I were you, I would rush and grab my my seat now. So with just a sum of 50,000 naira, you're going to qualify for the Python with data analysis training, right? So that offer lasts before the ending of January. So please, let's hurry and make payments. Now, Engineer Nebiat, before we call this a close, you have a few questions to answer. That's of Samuel and that's of Miss Dr. Obadimu.
Okay, so I think you've answered Samuel's question already. So to answer the question on the pricing, each of those 3 courses, the bill is 150,000 naira each. The first one, which is the Python, sorry, not Python, the data analysis using Excel, Power BI, Power Query, Tableau, and SQL. That cost is 150,000 naira, and we have already done it this year. Now, this second one, the Python for data science, where we will now look at Python with pandas, NumPy, scikit-learn, and all of those other ones. It's also 150,000 naira. And like Hilda has said, we are giving a discount to 50,000. We are essentially slashing 100,000 naira out of that training. So Samuel, that answers your question. The reason why we are slashing it is because we had already made a promise to those who participated in the first part that we will give a discounted rate, right? And that discounted rate is 50,000. But we have kind of also extended it that others can benefit from that discounted rate by paying 50,000 naira for that course, because that course is not a 50,000 naira course. It's 150,000 or even more, right? So that is the discount that we are giving. And like Hilda has said, that discount is a limited period offer. By the end of January, when we will start the course proper, we will not, anybody who has not made payment by then will not get that discounted rate. We will go back to 150,000 for that course. Then the last part of the course, which is the machine learning, which I'll talk about shortly, is also 150,000, because we are now going into more advanced principles of machine learning. And we are going to talk about things like neural networks, training machine learning models, and using them for prediction, using them for research, and all of that. That one is also 150,000. Now I'm going to talk a little bit about that. I can see some hands raised, but maybe we'll take those questions later. So the machine learning for research, essentially, it's going to be a machine learning course, but I've seen that a lot of people are not really interested in machine learning per se, because I think it's a mathematics part of it, right? Machine learning is mathematics, because a lot of the models that are built, they are mathematical models, right? Even though you use tools like TensorFlow and PyTorch, right, to build these models, but behind the scenes, there's a whole lot of mathematics going on. Now, but what I have decided to do in order to make it approachable, especially people who have specific use case, and right now the target audience are those who want to use machine learning for research, which I have come to see that there's a lot of people who are interested in that. They want to be able to do prediction. We just talked about predictive modeling or predictive data analysis. They also want to be able to do prescriptive, which is like actionable items based off of the prediction. So we have the third part of this, right, course, which is targeted at such people who are researchers, people who have a lot of data that they want to be able to make, meaning of that data. They want to gain insights, and they want to use it in their papers, in their research papers, and in their publications. That is what this third one is targeted at. And like I said, it's 150. We may actually consider some kind of discount again, for early birds in order to encourage people to register. And that will be announced separately, right? But it's good that Dr. Clement has brought it up, because I want to also bring it up here so that those who are interested, you can begin to plan for it. That course will come also next year. The timing will be specified, but it will likely come after the end of this Python for data analysis course, so that it's a logical transition. Once you have finished the Python for data analysis, you now go to Python data science and machine learning, with a special consideration for those who want to use it for research. So that is how we are going to progress it. That may come in the second quarter of 2025. So you can begin now to also plan for it. And if you want to be a part of that training program, you let us know as well. So I hope that answers those questions, and I hope it clarifies whatever questions that people have. Thank you.
So sorry that I jump in. The very
Yes.
first course that included or that involved SQL Excel, Power BI. You said you've done that already, am I right?
Yes, I know you register for that course. You
Time didn't
register for
allow.
that
So
course, but
is
I
it
don't think
possible
you
to
finished it.
bring it up again?
Yes, we will do it again. So every year we'll do it in a cycle. We actually are supposed to have done it in a cycle of, let's call it part 1, part 2, part 3, right? We're
Yes.
supposed to do that each quarter, right? Each third, let's not say a quarter, each third of the year. So we're supposed to start with the first one, then the second one, and the third one. But now we kind of, the first one, because of the delay and time synchronization and all of that, we now have this second one spilling over into January. So the third one will also come after the second one. Then we'll go back to do the first one later in the year. So it's going to run like that. But we'll look for a way to think it. So it's supposed to really be the first one in the first third of the year, the second one in the second third, and the third one in the third of the year.
Okay, thank you.
Yeah. Okay, so we have Okojon. You can go ahead with your question.
All right. Good evening, sir. My question is actually as regard the training. Will it be a physical training or is it gonna be still Zoom, just like today's Zoom?
Yeah, all our trainings are virtual. It will be on Zoom or Google Meet, depending
No,
on which one is more
how
appropriate.
about those that are around it? Is it possible for them to come around KodeHauz?
Well, I don't know about that. If it is at the time when KodeHauz is open, you can come to KodeHauz, but it's very likely that this training will be happening later in the day when KodeHauz will be closed. So most of the time we do this training in the night from 7, 6, 7, because that's when most people are back from work and can participate. And by that time, it's most likely that KodeHauz will be closed. So, but yeah, that's the situation there.
Okay, sir.
All right, thank you very much, sir. Do we have any other question? So just to reiterate, we have 3 links on the chat session. Please do well to click on them. We have the payment link on the chat. So if you click there, it takes you to where you can make your payment. And then we have the registration link. And we also have the link to the WhatsApp group. All those 3 links are very important. Thank you very much. So we have come to the end of this webinar. It was a very insightful one. I'm sure we've gotten a thing or two. Thank you once again, Engineer Nebia. Please let us give him another hand, give him another round of applause. Use your reaction button. Thank you very much, sir. So on behalf of KodeHauz and the entire team, we look forward to seeing you in the training program. Have a wonderful evening, everybody. The call is going to be open for a few minutes so that you copy these links so you can have access to them. Copy the payment link, the registration link, and the WhatsApp group link. Thank you very much once again. And see you by January.
I thought if we can join the WhatsApp group, all the other link can be posted on the WhatsApp group. Am I right?
Yes, you're right. Very right.
Okay.
You can do that as well.
Thank you.
Please, everyone here, if you are interested, do join the WhatsApp. Even if you are not interested, still join the WhatsApp group. That one is very important because once this call is ended, we may not have a way of reaching out to everyone. So do join the WhatsApp group at the very least.
Please don't end the call now, please. Some of us were using our cell phones that don't have WhatsApp, so we'll have to try to get to the WhatsApp through another means. So if you just leave the page like for maybe 5 more minutes or something.
Yes, we'll leave it. We'll leave the call running till 10 p.m. well, 10 p.m. West African time, at least for another 7 minutes, so that everyone join.
Okay, thank you.
Okay, so I can see a question on the chat that says, is it advised to wait for the first one again for newbies? If your question, what you are implying is you will not take this one, you want to wait for the next one, I would not advise you to miss this one, even if you did not do the first one. Rather, I would advise you take this one, right? And then afterwards, you still close your knowledge gap by taking the first one. The only thing I would tell is don't go for the third one if you have not done this second one, because this second one is almost like a prerequisite for the third one. But this second one is not, or the first one is not a prerequisite for this second one. So you can still go ahead and take the second one, even if you didn't take the first one. I hope that answers your question, Modu.
Yeah, Samuel, the payment link will be posted again.
Hmm? Huh? I didn't hear what you said. You said?